So in this video, we'll do a few more practice with quotient rule. So remember, the quotient rule is when we're dividing two functions of x or some other variable, and we can't simplify it. So we use the quotient rule when we're taking the derivative. We do always the low or the bottom function first times the derivative of the top function or the high function f prime of x minus that top function f of x times the derivative of the bottom function g prime of x all over the bottom function squared, or again, you can remember as low d high minus high d low over low squared. Okay. And I put the high with the derivative. You could also write it as like low and then the d high, whatever way works best for you remembering it. So in this function, we have to identify the low and the high, or the f and the g. So again, always start with that bottom function. And if you're consistent with that, that will be helpful. So the low or the bottom function g is 8x plus 10. And then f, which is that high function, would be 4x minus 5. And so then when we take the derivative of that bottom function, the low function, which is g, we would just get 8. And if we take the derivative of f, which is that top function or the high, we would get 4. And then we put it in this combination. So we write y prime equals, and I often tell students to just put the low squared right away because students often forget it. But again, if you do it this format, you can remember I always start with g and then I multiply by the derivative of the other. So I always start with the bottom and multiply with the derivative of the other. So I have low d high, derivative of that high, minus high d low all over low squared. And again, you don't have to distribute. You could if it asks you to simplify, but I can also just write it as like 4 in the front, 8x plus 10 minus 8 times 4x minus 5 all over 8x plus 10 squared. So that's my quotient rule with that. This one would be kind of the same thing. I would be using these rules, and I have a quotient, I have a division problem, so I have to use the quotient rule. I would say my g function, or the low function, is that 3x minus 5 squared. My high function, or f, is that 4x squared minus 6x plus 10. We're going to take the derivative of that bottom function g, which is, I have to use that chain rule. So again, with the chain rule, you start with the outside, which is the function squared. You bring the 2 down. You keep the inside the same. You subtract 1, so it's 1. And then you multiply by the derivative of 3x minus 5, which is 3. Okay? And then I can combine the 2 times 3. This one is a little bit easier because it's just the power rule on each term. So I have 4 times 2, which is 8, and then x minus 6x, which is minus 6, and the derivative of a constant is 0. And then it's pretty much just putting it in that combination. So again, I would always put the division bar. And if you tend to forget it, maybe put this first. So I have this squared and I have to square it, whatever that function is. Then I'm going to start with the low. So I have 3x minus 5 squared times f prime, or the d high, which is 8x minus 6 minus, and then I have high d low, so that f, which is the high, times the derivative of that 6, 3x minus 5. Okay, and then just to clean it up a little bit, we have 3x minus 5 squared over 8x minus 6. There's not really anything you can simplify there. This one, I would put the 6 out front and maybe the 3x minus 5. Doesn't really matter the order you do. Okay. And you don't have to distribute. Just be careful. If you do distribute, you only distribute it to one set of the parentheses, not both. And then if I have 3x minus 5 squared, well, when I raise an exponent to an exponent, I multiply. So it'd be 3x minus 5 and then 2 times 2, which is 4. Okay, and that's fine as a final answer. So that's a little bit more practice with the quotient rule.